Welcome back to section 15.4. We're now talking about box plots. This is another way to summarize how data is distributed. So in simple cases, a box plot shows the lowest data value, the first quartile, the median, the upper quartile, the third quartile, and the highest data value. And then a box is drawn around those first quartiles, and then whiskers are drawn to the lowest and highest value. So here are the box plots. Now what you can see from the box plots, they go directly to each other. So you can pause here and just kind of look at what you notice. Here you might say, hey, there are no whiskers, which means that Q3 is equal to the highest value. Here you can see how far away that lowest value is from that first quartile. 25% of the data is in here, 25% of the data is in there, 25% is in there, and 25% is in there. So although we're not going to work with more complicated box plots, there are other box plots that show outliers, okay? And outliers are data values that are much higher or lower than the most of the data, and usually they'll have like a little star, like, you know, there might be like a little star to kind of show like, hey, there's a point over there. But we're not really going to be dealing with outliers and box plots in this section. But at a glance, we can see where the middle 50% lie, and that's what's really important. This is the middle 50%. 50%, remember 25% each one, this is the middle 50% right here. And so we can see the middle nice and clear. And so we can see if they're symmetrically distributed about the median. So let's just read a box plot. What is the interquartile range of the box plot? Remember that the interquartile range is Q3 minus Q1. So remember that this is our low value, this is our high value. This is our Q1, this is our median, and this is our Q3. So our Q1 is going to be 1, 2, and our Q3 looks like it's 14. So our IQR is going to be equal to 14 minus 2, or 12. So that's how you can read a box plot. So now we're going to use this data about mathematical performance of 9-year-olds to make box plots for the following years, 1978, 1992, 2004, and 2008. You may assume that in each year scores range from 0 to 400, and we're going to use those box plots to compare. So let's get first thing, so we haven't built any box plots before. So first, let's start with a number line. And I'm going to move it up here so we're not going to get distracted. Ooh. Okay. So they said from 0 to 400. So let's just go by hundreds. 100, 200, 300, 400. Okay, so now they're giving us the percentile. Remember, the 25th percentile is Q1. This is our median, and this is our Q3. So we know that the scores range from 0 to 400. So that's our low and our high. So let's start with 1978. So we're kind of reading down here. 1978, we know the lowest value is 100. Q1 is 195, so that's about there. Median is 220 and 244. And we make a box around those, and our high is 400. And that's how you build a box plot. Let's do one for 1992. So our lowest value is still 0, 208, so it's about there, 231, and 253. Make a box around our quartiles. Highest is still 400, lowest there. Okay, let's look at 2004. Our lowest is still 0. 220, so that's about there. 220, 243, and 264. Okay, and our last one, 2008, starts at 0, 222, 246, 266. So we can see a lot of stuff right away, but let's start. So, all right, let's describe the performance. So we can clearly see an increase in scores over the time, right? The box plots are moving to the right, so there's an increase in scores. In 2008, we can see that the first quartile is slightly above. So the first quartile is slightly above the median, right? See how those relate? If we kind of just go down here. So we can see that that means that, so here we've got 75% of these students are all over here, right? And here we have 50%. So we can see, and 50%. So we can see an increase. So in 2008, we can see that that Q1 is slightly above the median. So we shifted up by like 25% better. 25% of students scored better. 75% of students scored above this level in 2008, but only 50% scored above that level in 78. So in 2008, the median, let's look at the median. The median is slightly above Q3. So we can even see that we're still just doing so much better than in 1978. We can see how that's improved over time. Let's look at another example. So this one is where we're going to do things a little bit differently, and it can be a little bit challenging, but in this problem, let's read it. Determine the median in the interquartile range in two different hypothetical brands. There's 40 samples tested. Now, I don't like to find data off of a dot plot because it can get really confusing. So normally I would say, hey, pull the data. So that would be 492, 493, 493, 494, 494. But I have to do this 40 times. That's not the most efficient. So I'm going to show you another way to do this. And that is by using the number of data points to determine where the median and the interquartile will be. So if we have 40 data points, the middle value is going to be the 20th to the 21st point. And we can, that's halfway across. So let's find that 20th point. Now, it does matter which direction you start. Once you pick a direction, that's the direction you need to go in. So if I start here, then I'm starting at the low. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That right there separates the first half. There's 20 below and then 20 above. So my median is between these 2 points. Well, they're both 500, so my median is 500. Well, to find my interquartile range, I need my Q1 and Q3. So if I have 40 data points, now I only have 20 data points in this first median, in this first half here, this 50% I have half. So if I have 20 data points, then the Q1 is going to be between the 10th and 11th point. Well, I already have those labeled. So there is my Q1. There's going to be 10 points here and then 10 points in this next section. So halfway between 10 and they're 497. So my Q1 is 497. Well, I didn't go in the other direction. I have to do the same thing. Now I'm going to show you what happens when you go from the top. And maybe you want to keep going and go say that it's between 30 and 31. That's okay. I'm going to count it back by ones here. So if I'm coming from the top, then I need to go 1 and then count from the top. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now I've got data points between 503 and 502. So my Q3 is going to be halfway between these two data points. And so, because that's going to, there's 10 points here and 10 points there. So it's going to be, my Q3 is 502.5, halfway between 502 and 503. So my median is 500. So for A, my median is 500, and my IQR is going to be 502.5 minus 497. So it's going to be 5.5 milligrams. Let's do for B. All right, so same thing. 1, 2, because I'm coming from the bottom, I got to start at the lower dot. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There we go. That's going to be, our median is 500. Interesting. Okay, now our Q1 is going to be between 10 and 11 still, so right there, 10 and 11. So that's going to be, Q1 is 499, but we need to get our Q3. So I'm starting from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right there. So it's going to be 501. So for B, our median is 500 and our IQR, subtract those two numbers, is 2. So you can see that it says use those two to compare. They have the same median, but I can see that the data is more spread out in A than it is for B, which means the milligrams of vitamin C is way more variable in A than B. Now it wants us to make a box plot. So let's start with our number line. Ooh, let's make it. Okay. And we can see we go from 492 to 507. So let's make it a whole number. Let's say 490. 495, 500, 505, 510. All right, so let's start with A. A, our lowest value is 492. Our Q1 is 497. Our median is 500, and our Q3 is 502, and our highest value is 507. So it's going to look something like this. And for B, our lowest value is 496. Our Q1 is 499, our median is 500, and our Q3 is 501, and our highest value is 503. So we can see that distribution right there. It says, suppose you only have the box plot from, I should say part B, and you don't have the dot plot. Use the box plot to discuss how they compare. So I can see that this data is much closer to the median, which quite frankly is the brand I would prefer to buy, so that my vitamins are all the same amount of vitamin C. I can see that brand A has more variability and brand B is more consistent because the IQR is less. You go ahead and give these a try, press play when you're ready to see the solution. And we'll continue on when we get back.